All right, our next speaker, please grab a seat. Our next speaker is Geoff Schmidt, one of the founders of Meteor, and today he is going to be telling you about the technologies behind Meteor.
Hey everyone, so some familiar faces, some new faces. Raise your hand if you've been to Devshop before, if you've come to one of these events. All right, so that looks like about 2/3 of the audience. So we're going to do a run through here, and we're going to talk about, what is Meteor really? And let's talk a little. We often get really far down into the details, but let's talk a little bit more at a high level about what we're building, why, where it's going, and what the big pieces of it are that make Meteor what it is. So the first thing I want to point out is there's a lot of frameworks in the world that we're used to using, things like Rails, Django, Spring, ASP.NET. Frameworks, they provide some scaffolding, some structure when you're building an app to make it a lot faster and easier to build apps. They take out a lot of the choices that the uninteresting choices that you might need when you're building an application. Meteor does all those things, but Meteor is also something more than a framework. Meteor is a platform. And when we talk about platforms, we think about something that's larger than a framework. We think about a whole technology base, a whole set of allied technologies that go together to be a way that we build apps. So these are things like Unix, or Windows, or Java, or the LAMP stack, the MAMP stack, all the different LAMP-like stacks. I call that hypertext, the 90s web. So what makes up a platform? Let's sort of, what do we mean when we say that Meteor is a platform? What are some other platforms? Well, some other platforms we've had in history, Windows, Windows is a desktop platform. If you want to write software that runs on a personal computer, you could use Windows. And Windows came about in a time when everyone was starting to have personal computers on their desktop, but it was very hard to program for one of these computers. You had to build everything from scratch if you just wanted an application that ran on your Apple II or something. So the genius of DOS, the genius of Windows, was that it provided all the technologies you needed to build a really compelling app that you could take to these personal computers that were starting to proliferate. So if you look at what's inside the Windows platform, there's a lot of pieces that come together to make that platform that you can build software on top of. That's everything from the whole idea of an EXE or a DLL, the file formats that underpin that, to the kernel that runs those programs, to the developer tools like Visual Studio, ways of drawing on the screen like GDI or WPF, ways of talking to other processes like the component object model, DirectX for rendering 3D graphics. These are all the different parts that happen over there in Dimension Microsoft, so you can write some great software that runs on a PC, or that talks over the network to build a client-server application like a lot of people did in the 80s and 90s. Or we could talk about Unix. There's a similar set of things that go together to make up Unix. You've got build tools like Make, you've got a kernel, you've got a compiler, you have things like sys5 sockets for talking over the internet. Now it's such a good idea, it's spread to basically everything now. You've got package systems like RPM or dpackage. And then, if we think about a platform that probably more people, or many people in this room are really familiar with, it's like the hypertext platforms from the web that we built in the 90s. So this is, if you look at what a modern app written on top of this, these hypertext platforms look like, you've got Nginx, you've got Postgres, you probably have a framework in there like Rails or Django. You might have Apache or Memcache, lots of different options for these technologies. But that's the web platform. And when we say the web platform, I say hypertext instead of web, because we reached a point in history where we need to be a little bit more specific. Because there's the platform that the web used from around 1994 and 1995, up to, a couple years ago. And there's the platform that most of us are building our apps on top of now. And this new platform, it's got things inside of it like Angular or Sock.js, or Node.js. It's really different from LAMP stack. It's really a whole new platform. And so what Meteor, and it's interesting because it's a much less mature platform. We're at an interesting turning point in history where it's like it's 1994 and we're writing web servers in C. Everyone knows that we want to get these applications out there onto this World Wide Web, but the technologies aren't that mature. It's not really clear how they should all fit together. And we have to do, if we want to build one of these applications, we have to roll a lot of things ourselves. And some of this, sometimes you can do this by fitting together open source components you find and having to do a lot of experiments yourself to figure out really how it works, design your own architectures. Sometimes you really do have to build some really difficult and tricky tricky components from scratch. So with Meteor, what we're really trying to do as a community is we're trying to build the first client cloud, we call it, platform. Just like how Unix was a great platform to use on time-sharing systems, and Windows was a great platform to use on PCs, and the LAMP stack was a great platform to use to deliver customizable hypertext to millions of people at once. We're trying to build an open source platform for this new, call it, client cloud era. So client cloud, what's that? Well, here's roughly the progression that application platforms have taken over the last, well, as long as our species has been experimenting with computer applications. First, there were mainframes. And then there's a big change. We all went to client server. For applications that talked to the network, that worked with data, we had the client server era, where we had these PCs that talked to services in a data center somewhere. And then there was another big revolution, and we went to the web, the web of hypertext. And now something new is happening. We're moving to, it's as big as a transition from mainframes to PCs, or from PCs to the web. It's a transition from the LAMP stack to this new way of writing applications. So what is this new way of writing applications? How is it different from the web we had before? The big difference is the devices. It's not just a smart server and dumb clients. It's actually a distributed system. So we have supercomputers in our pockets now. They're called iPhones. And also, when we talk about the server side is different too, because when we thought about building client-server applications in the 80s and 90s, and that was really the last time we had smart devices, we had PCs. At that time, we still thought in terms of servers that go in a rack somewhere. But now when we think about the services our apps talk to, we're actually thinking about distributed services that exist in the cloud, that are spread over multiple data centers, that are highly available, that have to synchronize between different regions. And I think if I were to summarize what the big points of these new kinds of applications we're all trying to write are, you could say they're reactive, distributed systems that run on diverse architectures that put data on the wire. So let me go through those things one at a time. So by reactive, what I mean is, generally what happens is, it's not I do a query and I get back a response. It's something changes in a database somewhere. Then we need to respond to that event that happened. And we respond to that event by finding all the clients that are affected, whether that's tabs in a web browser or mobile devices, and telling them about the change. And more people are starting to talk about this paradigm of reactive applications. It's a great web page, if you haven't seen it, the Reactive Manifesto, that is more coming out of the Java community, saying, OK, when we think about our services that we're building in our data center, we need to think about these applications as being reactive. So Meteor is reactive from top to bottom, and just about any client cloud framework has to be. And that's not because we really need to have our stock quotes update immediately. It's not about real time. It's about the fact that we actually have to synchronize. It's about the fact that we're in a distributed system. Like, our applications are actually running in this web browser. They're running on this mobile device. So when a change happens, we have to push the changes down to them just to keep them up to date. In the hypertext world, we didn't have to do that because we had page reloads. You had to reload a page if you wanted something to change. But since we don't have page reloads anymore, we have to have reactivity. We have to proactively push these changes down. We have all the problems that distributed systems have. And when you think about a distributed system, the thing is, all the clients are now nodes in the distributed system. So your web browser is a node. If 1 million people are using your app right now, each of those people is a node that has to be informed of changes. Every iPhone out there, every Android phone out there that has a cache of some data on it is a node in this distributed system. And many of the same problems we have when we think about distributed systems on the server, suddenly we have in keeping all these clients up to date. And the other thing is, we think about this distributed system, all the nodes in it. The nodes, they have a lot of different architectures. So when we think about architectures, we're used to thinking about, Windows architecture, Linux architecture, Intel architecture, PowerPC architecture. But now we have a whole other set of architectures called like the W3C architecture, like the HTML5 architecture. JavaScript is turning into bytecode, kind of like JVM. You can write your app in CoffeeScript. You can write your app in TypeScript. And it's just like writing your app in Scala versus Clojure versus Java and running on the JVM. Really, browsers, this HTML5 world, have turned into a compile target. And we should treat them just like the other compile targets we have, just like PowerPC or Linux or Windows. And finally, the other point is, these client cloud applications, they put data on the wire instead of presentation. So the 90s web put presentation on the wire. We just send HTML around all the nodes, but now we do something different. We send data to the nodes, and that's because we're doing the rendering down there on the client, because it gives you a better user experience. It gives you those animations, it gives you those nice pop-up dialog boxes, it gives you not requiring people to reload the page when something else happens. That means we need to send data around instead of HTML. So this client cloud world, this is the world of HTML5 as a platform that you can run your application on top of. This is the world of mobile. Mobile devices were always part of the client cloud world. This is the world of AWS and other cloud infrastructure providers where your app is actually distributed all over the world on these boxes in the cloud. This is also the world of the Internet of Things, because you think about 1 million users accessing your app simultaneously as being a lot of nodes in your distributed system. Wait until we start talking about all the sensors that are out there in the world as we start to actually instrument all the things in the world and make that part of our application too. OK, so don't have a lot of time today to go through in detail how the Meteor platform works. But I'm going to skim through, we see here like the technologies that make up Meteor. Skim through that really quickly just to give a sense of what a modern client cloud platform looks like and the direction that we're going with Meteor to try to develop the best and really first open source client cloud platform. So one of the core technologies inside Meteor is we don't really have it a name yet. You know it because you type Meteor Bundle or you type Meteor and it just works. But I think we're going to come up with a brand for it. Probably going to be something like Unibuild, Unipackage. It's Meteor's build system. So it's a tool like Make or Sconce. It's a build tool. And the really cool thing about this build tool is you start with one source tree, one source tree of your application, one package system, and you can target. You can from that one source tree, you can build for multiple programs that are going to run on different nodes in your distributed system. So in Meteor today, you see that because you have a server program that runs on like Linux, and you have a client program that runs in the browser. But really what's going on here is this is a distributed system build tool. It's a tool that understands we're going to have one code base that might be written in multiple languages. Then we hit build, we get multiple build products that then go different places. They go into the Apple App Store. They go into your web browser. They go into an Arduino in a sensor. They go into AWS or Azure or Rackspace, like to run in the cloud. And so and it's really cool that we can have one package system where you can share code between all these different deploy targets. And it's really cool that we can provide all the things you'd expect in a build system, like source level debugging, for example, with source maps. So to get a sense of where this is going to go in the future, imagine what it's like if you can write part of your app in Clojure, and then have, when the server part of your app, that Clojure runs on top of the JVM, and the client part of your app, that runs with ClojureScript right on top of the JavaScript VM. Or imagine you could write part of your app in C, and on the server, that's native code, and on the client, that goes through Emscripten and asm.js. The point is, what we're really trying to do when we write these applications is we want to have one code base, multiple languages, multiple targets, multiple architectures. So next thing to talk about. So DDP, I said we need a protocol for delivering data in this distributed system. So the protocol we used for the web, for the web we had HTTP, and that was a great protocol for delivering hypertext, delivering these cacheable static assets. But what we're seeing people do today is we're building apps that don't need to deliver hypertext. They don't need to deliver static cacheable assets. They need to deliver data, and they need to synchronize this data between all the nodes in the distributed system. And what everyone's doing is they're building their own custom protocols that are basically the same, but the message is named something different in everyone's implementation, so they're not interoperable. So all we need to do is we need to take these custom protocols that everyone's building on top of WebSockets and on top of long polling and standardize what we're going to name those messages. That'll give us interoperability. Why is that important? Well, we got a lot of great things from HTTP when it comes to interoperability that we've lost with this forest of custom WebSocket protocols everyone's building. And we can get those back by using DDP. So we can have shared tooling. So in the world of HTTP, we can make these caching proxies. If we all use the same protocol like DDP to synchronize the data, we can build caching proxies for the data that we're delivering to our applications. One person can write that caching proxy. Then anyone who's trying to synchronize data from a server to the client over a WebSocket can use that caching proxy. We can have interchangeable parts. You can have a different framework on the server and on the client. And people are doing this with Meteor today. They write their server in Java. They use the Meteor tool set for the client. Or they use the Meteor JavaScript stuff on the server, and then they write a native iOS client that talks to it over DDP. The other thing is APIs. When's the last time you saw an API that ran over WebSockets? You'd think we'd have these all over the place because we want to expose these awesome real-time services we're building, but it's just too hard to specify those APIs. So we need something where the specification for an API for one of these great real-time services everyone is building fits on a page. So this is all possible with DDP. Livequery. So this whole reactive system isn't that useful if you don't have any way to get reactive data out of your database. So Livequery is an alien technology that turns your database into a reactive database with streaming queries. So in other words, instead of just saying, select star from people and getting all the people in the people table, I can say, select star from people. Don't just give me the results once, but stream the results to me. Like whenever new rows are added or removed or when they change, send me those updates. Give me an update stream for an arbitrary query. So that's, and so we have that for Mongo right now. And it's implemented by connecting to Mongo as a replication slave. And of course, just like with any database query, some queries are efficient, some queries are something other than efficient, and you have to do some thinking about what things are safe and performant, and database optimizers can improve over time. But there's nothing fundamentally tied to Mongo about the Livequery approach, and I think we even have an exciting lightning talk tonight about some more directions here, but we'll be starting soon on SQL. Deps, the unsung hero of Meteor client-side programming, it's a library for transparent reactive programming. So it's incredibly tiny. It's about 1 kilobyte, but incredibly powerful. So Deps takes your normal JavaScript code and makes it magically become reactive. So if you've been using Meteor, you've probably been using this and haven't even thought about it. So here's some code, and it's a function called selected person name, and it just returns the name of the currently selected person in uppercase, or nobody if no person is selected. But you know what? In Meteor, this is reactive code. It's automatically reactive, transparently reactive. Meteor, using deps.autorun, you can call this function, get the currently selected person name, and get an update whenever the output of this function changes. Whenever the current selection changes, we'll get an update. Whenever the name of the selected person changes in the database, you'll get an update. And when these updates happen, the value is transformed by going through to uppercase. And this is an alternative to, in other systems, you might have to do polling, or dirty checking. You might have to wire up a whole bunch of events to listen for a selection change event, a first name change event. Or if you're using a functional reactive programming system, you'd have to create a bunch of nodes and chain them together, like a node that represented the selection, a node that represented the getting a person from the database, and a node that represented putting in an uppercase. You have to chain all these nodes together. But with Deps, you can just write arbitrary JavaScript, and it just works. All in 1 kilobyte. What a deal. Blaze. So Blaze is a library that works with Deps to do reactive DOM updates. So Blaze is another amazing, a lot more complicated than Deps. But you just write a familiar looking template, in this case in handlebar style, and this template automatically updates live. So when a new person is added, there'll be another element added to the list. If the first name or the last name of a person changes, it'll change in place. We're calling our selected person name function that we defined before here. All of these, Blaze will find a way to patch just the part of the DOM that's changed and keep this in sync, replacing what would have had to have been a lot of logic to rifle through the DOM, find the right nodes, and make the updates. So there are other libraries out there that provide the same sort of kind of reactive DOM updating. And compared to those, the big things that Blaze gives you are, it doesn't have any kind of DSL or directives that you need to use that are special. And it's also template-based. So you don't have to write JavaScript to construct the page. You can just write a template. And people have different preferences for how they want to write their front-end code. And so you can swap out Blaze for Angular or React or whatever library you prefer. But we found that a lot of people really like this very simple way to just write a template and with no extra work have it become reactive. So I think that looks like I have no time left. So if you are interested, I encourage everyone to come check out David Greenspan's talk about Blaze tomorrow at HTML5 DevConf if you're coming, which will be a much more in-depth introduction. Sorry? Oh, sorry, excuse me, Thursday. Over the next couple months, we're going to be producing some much more in-depth content about each of these parts of Meteor and going into how they work, not just on the level of a slide, but like full detailed information about how these parts fit into this client-cloud architecture of the future and how you can use them either with Meteor or independently. In the back.
DDP is great for these sort of high volume connections. What about long life, low volume connections that currently like red hooks and all are probably better for?
What about, so the question is, so DDP is great for a high volume interactive session where I'm logged in, I want to keep the page up to date. What's the solution for, let's say there's an API, if I have this right. There's like, let's say I want to monitor someone's Facebook page and get called back when they change their job on Facebook. Could DDP be the API that Facebook uses to expose this instead of webhooks? The answer is, so DDP is designed to, like right now, DDP is, right now, when you disconnect from a DDP connection, the server forgets the connection state. But there's actually a protocol feature for DDP that's designed out so you can actually shut down that DDP connection and then reconnect later and resume your subscriptions where you left off. So that's useful in two scenarios. One scenario that's useful for is power saving on mobile. So for mobile, you might want to not be connected all the time. You might want to connect, get some updates, and then drop the TCP connection to save some battery. So then the question is, how do you know when to reconnect and get some more data? And a related question is, you might be monitoring lots of things on the internet that change very slowly, like only once or twice a year or once or twice a month. In that case, we might also think about dropping the DDP connection and wanting to get a callback. And so the idea is that, though this hasn't been implemented yet, the idea is DDP will have a way to quiesce a connection and say, here's how I'd like to be called back. So that could be with a webhook. That could be with a push notification on a mobile platform that has a more battery efficient way to deliver push notifications than you could deliver yourself. So yes, absolutely. On the roadmap for DDP is a way to quiesce a connection, whether that's for a minute or for 10 minutes because we think updates only come every 10 minutes and we want to save battery, or for a month because we think this is a data source that changes very slowly. And the DDP protocol was designed with that in mind from the beginning. Does that answer the question? Yep. Other questions?
We have a question from Twitter.
From Twitter.
What is the .star format?
What is the .star format? A .star is like a .exe except for loading into Galaxy. It's a little bit analogous to a slug on Heroku or a war or ear in Java land. So in other words, it's a bundled cloud service that you can go run. We'll have more to say about that when Galaxy is released.
In your list, you didn't say anything about fibers, and that seems like a pretty useful thing, at least for me, for programming sense. It makes it a lot easier to program.
So the question is, I didn't say any in my list about fibers. Well, that's because I think everyone should be using fibers. I didn't say anything about oxygen or water either. Fibers are not the solution to every problem, but they sure do make it easy to write business logic. So the way I think about this is, there's sometimes when you're web building, it's something like a message bus, where you have a whole bunch of concurrent events that don't necessarily have a lot of state, or you can build a state machine around that and like really model out what that state is. In that case, there may be situations where it's easier to think about that problem, especially if you want high performance, as a bunch of asynchronous callbacks and events. But I think in most cases when people are writing complex business logic, where I want to talk to some servers and then do a thing and fetch something from a database and then do a computation, it ends up being much easier to write that code in something that looks a lot more like a straight line way. And I think some of the reasons why people, like Node has trained people to worry about synchronous calls, because if you're not using fibers, they block the event loop, and that's really bad. And the thing that's excellent about fibers is you can actually preserve that same coding style where you write a series of function calls and you're able to use the return value from each function call, and you have a nice clean stack, and you have events that propagate the way you expect. While not actually blocking the event loop, while still getting something comparable to the same performance. So yeah, probably should have been on the list.
Another question from Twitter. Daryl from Australia says, hi, Geoff. Can I make a DDP server in another language?
Absolutely. So do I need to repeat that question? Or you might?
I might.
OK. Yes, you can absolutely make a DDP server in another language. And I think there's something like a dozen independent implementations of DDP, not counting the one in Meteor Core. So I've seen everything from, so there's a project where they have real-time financial data coming into their Java server, and they have their proprietary financial models that are running in Java, and they've implemented a DDP server so they can write their Meteor, they can write their client and their front end entirely in Meteor, and they just call meteor.connect to connect to that backend service. And even though this backend service is written in Java with no Meteor code, it speaks DDP, and like everything on the page updates live. You can do it the other way around too, where you use the Meteor server and you make, like, let's say, a native mobile client. You write an iOS client or an Android client that just has a DDP library, and you can make those same live updating subscriptions and get like reactive pushes of data from the server to your mobile device if you don't want to use HTML5 JavaScript technologies and want to go straight native. There's even a brain scanning microscope that uses DDP to manage all the processes that are involved in slicing a brain very thinly with a diamond knife, and then like scanning all the brain slices, and like positioning the microscope stage with like nanometer accuracy. And so they wrote, and a lot of that is data acquisition is run by Windows boxes because the drivers are only available for Windows. So they have made that's all run by DDP infrastructure, including the image acquisition. And it's really cool because they have a Meteor dashboard, and you can see the current position of the microscope stage, and it's measured in nanometers, and it's fluctuating back and forth by a couple of nanometers in real time as it's like vibrations in the room. So yeah, the spec of DDP is just a couple pages. You can find it in the live data directory of the Meteor repository. It's not hard to implement at all. And we'll be doing more in the future to get that standardized and promoted a little bit more and start an active effort to encourage more services to be built on top of DDP post 1.0.
What is Galaxy?
What is Galaxy? So right now with Meteor, you can type Meteor deploy, and you instantly deploy your app to free hosting provided by Meteor Development Group. There's a quick, easy way to try out deploying a Meteor app. So Galaxy is like a much more powerful version of Meteor Deploy. So with one command, you can deploy your app into it's like your own cloud hosting environment. You can think of it as something like Heroku, except contains more Meteor-specific functionality. So functionality like being able to do hot rolling code updates. So when you deploy your app, doing seamless transitions for every client that's connected, or doing good DDP proxying, so it's easier to split load between servers. So it's basically our answer for what's the best way to do the DevOps for your Meteor app.
One more question from Twitter. Will it be possible to hook at Unibuild to customize Meteor's build process from a Meteor package?
The question is, will it be possible to hook Unibuild to customize the Meteor build process? I love these softball questions we're getting. So yes, the idea of Unibuild is that it should give you all the power of a build system like Make or Scones, but it should be really easy to use. And the way that we've come up with doing that is the idea that packages in Unibuild can both contain code, but they can also contain extensions to the build system. So right now, there's a few of these in Meteor already. Things like CoffeeScript or Less or Sass. So these are packages that actually contain build plugins that they extend Unibuild by adding a new compile rule, to use Make terminology. They say, oh, if you encounter a file that ends in .coffee, run it through this process, which is arbitrary code inside this build plugin, and then inject that right into the bundling process. So, and these plugins know how to participate, for example, in source map processing, so the source maps will get chained together as necessary. Right now, it's not actually necessary. So that is what we've done so far in Unibuild. In the future, there's a few other parts of the Unibuild pipeline that are still fixed function. So minification is just something you can turn on or off, but you can't customize. It's built in. You couldn't have added minification if it weren't already there. That's something that eventually, I don't know what time frame, certainly post 1.0 will change. So minify will just be a plugin that you can, a package that's included by default, that is a source-to-source transformer that inserts itself as a later stage in the build process. There's a lot of interesting things that become possible when we have these packages that hook into the build process. For example, automated test coverage analysis. Some really cool things you can do if you post-process all the JavaScript you've generated to add a little bit of code to instrument, say, oh, this basic block ran, this basic block didn't. That lets you do automated test coverage analysis. So definitely a very exciting frontier for Unibuild. Are we out of time?
Yep.
All right. Thank you, everyone. Yeah.